A lot of the projects that I make sometimes take weeks, if not months, to design and build. So what if I only had one day? 24 hours to design, build, and complete a project. It is currently 6:30 in the morning, so 24 hours from now, I want to have something done, built, and sitting in front of me. And I think I have the perfect idea for that. I want to build a mechanical scissor lamp. The regular ones have this wall-mounted telescoping function to them that extends out the light that's on the end of them. But for my design, the whole thing is a light. Imagine a scissor mechanism where each of the linkages glows. When it's compact, the lights are off. But as you pull and extend the lamp, the light gets brighter depending on how far you expand it. So that's what I want to try and make. I have no idea how to do that, but that's what the next 24 hours is for. But I've already wasted a lot of time this morning explaining all this, so let's just get building. To begin, when doing something new like this, it's helpful for me to make a quick small-scale test. I just want to build a cardboard mock-up to just have something physical to actually touch and mess around with, to also make sure that I even understand how this is supposed to work with the linkages and the joints. So the cardboard mock-up version is done, and it works ridiculously well for something that is made out of essentially garbage. But I think at this point I've gotten everything that I need to out of the mock-up version of this, so I'm going to take everything that I learned from this and move into the computer to try and actually make this into a real thing now. Usually I would spend this early design time making a bunch of different iterations just to explore what's possible. But for this, I spent a good amount of the time just trying to find a good balance of everything. I want this to be visually interesting, but I also need to work with the materials that I have on hand. I want this to be pretty big, so I need to think of what I can laser cut or 3D print, all while still trying to complete this within a day. And I thought that I was doing a pretty good job. Until I had an idea. So let me show you where I'm at right now and where I think this is going. This is the shape that I decided on for each of the linkages, and I figured that I could laser cut some wood to make up most of these pieces. The bottom and the sides could just be the regular stock plywood, and the ends could be stacked up out of laser cut slices to achieve that curve. And then finally, the face panel gets acrylic for the light that's going to be behind it. But I had a new idea. What if I instead make everything out of acrylic? So instead of just having one lit face on this mass, the whole thing is just a glowing bar of light. Even if I use frosted acrylic, it's still going to be more complicated because you're going to see the interior parts of it more with the shadows that emanate. Emanate? Is that the right word? Emanate. Issue or spread out. Okay, that's right. So everything on the inside needs to get planned out and cleaned up so that it looks good when everything is lit up. And I can't just shove everything into a wooden box like I was hoping to do. It's 2 o'clock, so we are now 8 hours into my 24-hour challenge, and before me laid out on this table is all of the work that I have to show so far. It's nothing, but that's going to change soon. In the last few hours, I have completed nearly all of the design for the acrylic version and then mapped out all of my cuts, so I should have enough material. And I have the acrylic housing cutting in the background right now because that will answer some of my other questions. I'm going to build one of them fully just to see if it works the way that I want, and if it does, then I can mass produce them. All of the test acrylic pieces came out really nice. The only issue was I completely forgot to add the screw holes before I sent them off to get cut, but I made a really quick jig and got all of those added back in. The problem now is that I need to 3D print all of the end pieces to see if this is actually a good match, and a set of those takes over an hour to print. So while I'm waiting for those to finish printing, let me tell you about PCBWay, who sponsored this video. PCBWay has everything you could want if you're looking to have parts made. Circuit boards, CNC milling, 3D printing, injection molding, you name it and they have it. When I had them 3D print aluminum metal components for me, the process was simple. I took that file, I chose the process that I wanted, I chose the material I wanted, and got an instant quote on it. They have so many different manufacturing options, so if you want to see how they can help you prototype your parts or help you with your next project, check them out through the link down below. And thanks again to PCBWay for sponsoring this video. With the test 3D prints done, I can start joining these together. The 2 cylinders will become the sleeve joint for the dowel that will join both of these sides together. The other 3D printed parts can get adhered to the ends of the acrylic pieces, and then that will be the location that everything can get screwed into for the other faces. At least, that's how it's supposed to go. For the last 2 hours, it has been nothing but problem solving. So issue number 1 is with these horseshoe shapes at the end. Both of these ends are slightly misaligned, which is going to be a problem. I thought that I could just eyeball the placement of these, and I, in fact, should not have done that. So moving forward, I laser cut a template for me to follow to give me guidelines on where the pieces should actually get glued. Since the acrylic can just sit right on top and I'll know exactly where to put them, and I can just align it with the engravings down below. The other issue is for the rounded corners. When I cut these out, the plan was to just bend it around the corner. These are surprisingly stiff for the thickness that this is, so I need to find a different option, which is why I laser cut a bunch of half circles and glued them together to try and make a form that I can use the heat gun on to hopefully just melt this and make it more malleable to at least get it close to the radius it's supposed to be. In between all of this, I also designed some new improvements to the housing for the future, and I'm going to 3D print some connection points for along these edges so that there are places to screw into to keep it from bowing out. You might also be wondering why I am 3D printing parts that would take 20 seconds on the laser cutter instead of 20 minutes on the 3D printer is because this is made out of transparent PETG. This material will let some of the light still pass through it where other PLA or solids wouldn't. And in the past, I've had some problems screwing into acrylic, hence all of the different connection points. So it really is my best option right now. In between all of these parts being made, gluing them up and assembling them, I've been trying to think of how to actually make the lights for this project work. Like how to actually make them function so that when you extend the light up, then they get brighter. Now, the obvious way to make lights work like that is going to be using a dimmer switch, but I didn't exactly know how to incorporate that in all of this until I just had a little Jimmy Neutron brain blast moment here. So when these parts actually swivel to extend, when these parts swivel to extend, I can use that movement to control the dimmer switch. If you imagine the dimmer switch being statically attached to one section, and then in the center, the knob portion is attached to the opposite side, as they twist to extend, that will also turn the dimmer switch. This might be my most creative solution in this entire project. Genius. In about 30 minutes, this sweet little naive child is about to learn it is not that easy. A complicated joint type, more wiring to do, adding a gear ratio, just more objects to cast shadows within here. There's a whole lot of reasons why that's a bad idea and why I switched. But he is still a little bit of a genius because he thought of a rack and pinion setup shortly after. The general idea of it is the same. It's just capturing the sliding motion of that bottom leg and using that to turn the dimmer switch that can be hidden within the base. I'll talk about that later in the video, but I realized that this night, I never actually recorded switching those ideas after I found those problems. And instead, I realized the only footage I have of that was me just wildly swinging around that new dimmer like nunchucks. So, not very helpful. Throughout the night, the cycle of problems just kept going. I needed to hand sand all of the faces of the housing since that was the only process that I found that I could get a consistent uniform result with the orbital sander and other sprays not really working as well as I hoped. Not to mention, I still have so many different parts to assemble. I still need to cut and resolder the lights to go in here. I need to make the base for all of this. I need to work on the joints for each of these connections. It is still a daunting amount to do. After midnight, I tried to just not look at any clocks. I didn't want to even know what time it was. I just put on music, kicked it into high gear, no distractions, just building, and parts started to come together. All of my designing and planning finally starting to manifest. 24 hours of straight work leading to this. With every piece, I got closer to finishing until finally 6:30 the next morning. If I'm being honest, I was not even close. I was feeling pretty bad and honestly defeated right about now. The only thing that I was happy about was that I could finally go to sleep. Is what I would say if I was a quitter. But I got that grind in me. I'm ready to go for another 24 hours until this project is complete. Oh, nope, he just forgot his phone. Okay, never mind. Looking at all of this now, it's hard to imagine that I thought this was going to get done in a single day. It is kind of delusional, but I'm delusional, so it fits. A little part of me is still disappointed I wasn't able to complete my challenge. Don't get me wrong, like it was an insane amount of work, and I think it was good quality work. Like you can see the difference in the build quality from the first version I built to the second one when I started to slow down and really care. So now with no time limit, but my own desire to see this through, there's just a couple of things to finish because it is actually really close to being done, even though it doesn't feel like it. So I have 9 out of 10 segments built, and I'll make that last one, and the remaining things to do then are just to put the lights in, to cut the joints, make the curved ends, and then build the base. The first thing that I built was a second half to the acrylic heat bending mold, and it works so much better now. Once again, you can look at the two parts next to each other and you can just see the visual improvement that it makes. It makes me a little embarrassed that I thought the first one was good. With the improvement to the form for the ends, it revealed a much more annoying problem, and that's shrinkage. When fully heating up the acrylic again, it starts to shrink a tiny amount in the direction that it was manufactured, which was so confusing to figure out, but it makes sense now why some of my parts were short or they were too thin, and there was absolutely no consistency since I was just filling the bed with cuts. Luckily, I got the settings dialed in pretty good, and I was able to solve it on my first try, right after my 7th attempt. With the final curved components done, the housing is finally finished, so it's time to move to the inside. I designed one final part for the light to slot into, and I can adhere that to the cylinder that's on the interior at both ends. Before I can actually solder the lights in, I need to build the joints. I bought a dowel that I can cut down to fit in the 3D printed tubes. To secure all of the dowels within this joint, I'm going to use some small 3D printed parts that can just screw in as well to keep the system really lightweight. The only joint that's a little annoying to make is going to be the one at the top center, because that will control the position of the entire system. So I did what I do best, and made this really overcomplicated. This is a 5-part component so that it can span across 2 pieces, rotate freely, fit the light, and act as a controller. As you turn the bolt, the cylinder squeezes in on itself and the walls, and it locks up the joint. Because this whole system is linked and is one unit, when one joint doesn't move, nothing moves. So by turning the knob slightly, it will act the same way that the arms do that I made for my desk, and it will hold everything in whatever position you set it to. It's at this stage though that I got another reality check. My joint design is kinda garbage, and it's showing. The top one is fine, it's all of the other outside joints that are causing the problem, and it can't even hold itself up. This is where I started to panic, because I was so confident that the tension in the top joint would be enough to hold this. So much so that I never even considered a backup option. So I had to stop, and I went back to the drawing board, and the next day I came back with some really good changes. I swapped my plastic caps and my wooden dowels for steel bolts, and with these I should be able to apply more friction to help the joints stay in position. I also replaced the small 3mm spacer ring that I had with a much larger rubber gasket to give this even more friction. My only concern with the new design is that these components weigh literally 6 times more, and it just adds up. But I'm hoping that the increased functionality more than makes up for the increased weight. Okay, first things first, everybody's gonna be cool about the gigantic mess that keeps growing and just gets shoved into the corner of my living room. It has been a chaotic 4 days. That's right, I am now on day 4 of what I thought was a 24-hour project. But I at least have this working now, and when the pressure from the top dial is released, perfect. Well, almost. You will notice one pair sitting off to the side. I'm gonna have to eliminate one section from this and only do 4 groups instead of 5. Because it is just getting simply too heavy to support itself, and it's making all of the joints work harder. So now that I know that this actually functions, I can finally add the lights and wire this up. I cut up all of the LEDs to match the length of the interior, and then I needed to peel away some of the silicone to be able to access the tiny copper contacts to solder to. Getting the wiring to jump from one piece to the next, even when they're moving, thankfully I solved earlier in the version 2.0 housing. To not have the wires get damaged or just sheared off when these pieces move, I added some slots on the interior side of these joints so that the wire can be fed through and it will always have a safe spot to cross over even when these pieces rotate. I tried to do a lot of the soldering before I put this into the housing since it will be much harder to solder once they are in there, but even connecting the first light segment to the next was proving to be difficult due to the lack of working space in here. To try and help with that, I bought some wiring clamp terminals. They just press down so that you can feed the wire in on both sides and it connects the 2 parts. It's still not a perfect solution though. I still struggled with this a lot sometimes. Trying to fit my fat little fingers in here, or even just a thin tool, doesn't always help. But I know that trying to solder all of this would have been even worse, so I'm still happy to have done it. Okay, one last little test to make sure everything still works. So that is just barely on, and that is maximum. Nice. Okay, let's keep going. Now that everything on the top portion of the lamp is all done and ready, we can start working on the base for it. And for that, we're cooking up something good. Pasta. There are many different ways to cook it, but this is my secret family recipe. Of course, you start with water. Next, you can add your ingredients. I picked up a delicious bag of my go-to favorite 5,000 pound concrete mix. Go ahead and add that to your water, and you can also add some seasoning of your choice. I always enjoy some good multi-purpose sand. It really gives that dish the texture and flavor you want. Give that all a good stir and let those flavors blend together. And then you can transfer that over to your baking tray. Try and balance everything out so that it all cooks nice and even. Once you have that, you can go ahead and pop that in the oven to cook. We're gonna do a quick 5 minutes at 1.2 million degrees. The temperature of the sun's corona really brings out that nice crispy texture. And that's all there is to it. Now, you have a beautiful pasta dish. Just like how Grandma used to make. I have no idea what's happening. I never actually finished writing how this bit was gonna transition back into the rest of the story, so it kind of just ends here. So I'm just gonna hard cut randomly, and we're just gonna I laser cut out one final piece for the bottom panel to place all of the base components onto. There are 3 main parts that need to get put onto here. I need one base connection to slide, I need one base connection to remain static, and then the final part is to house the dimmer switch and all of the different mechanics. For the movable connection, I took inspiration from camera sliders because I realized that I already had most of this designed and modeled just in different components throughout the project. So I threw all those together and I made this. Look at that. At the same time, I also made part 2 out of 3 as well, since this is just an easy connection in comparison because it's a simple static joint. The third and final component for the base is the housing and the mechanics to make the dimmer actually work. The way that I imagined this working that first night was that if one leg moved, I could essentially make a rack and pinion system to turn the dial of the dimmer with that sliding motion. After sorting through all of the math to make that actually work, turns out what I want cannot physically exist. My bad, should have looked at that sooner. Here's the problem, just simplified. The sliding leg travels 4.5 inches from start to finish, and on the dimmer switch, the minimal power to turn on the lights is about here, and their max brightness starts right about here. So in a rack and pinion setup, to travel 4.5 inches to turn 135 degrees means that there's a giant dial gear that's sticking out of my nice little housing cover, and it's not even in plane anymore. Although it would be a fix, I have suffered through enough gear chains and ratios for one lifetime, so my solution to this is easy, but it's not as clean. I can take that whole system and just turn it 90 degrees. I tried to make everything on the base very easy to assemble. The wooden plate can slot into the forms on the concrete, and then all of the base components can sit inside there. I really liked the look of concrete with the acrylic, but it's also just heavy to help the base remain steady when the lamp is pulled to its highest point. To get the base connections in place, I glued the first one down, and then I put the lamp on so that I could see exactly where to put the second one and make adjustments as needed. I was assembling the dimmer portion and decided to test it out to make sure that the slide function still works. And I noticed a problem. The problem is not actually with the dimmer slider. This thing works fantastic. I am unreasonably proud of how well this works. The problem that I found is actually with the lights. When I was looking through the footage for the assembly process on this base, I noticed that some of the lights are really dim. These two being more dim makes sense because this is a longer travel path. To get to this point, the power only travels 16 inches, but to get to this point, it's over 144 inches. All of this to say that on the base, I will need to add one more component. From a little more research, it looks like you can actually power LED strips from both ends. And I'm hoping that the split wire configuration will give more power to the end of this daisy chain and will help lessen the visual difference between them. With that fixed, I can get back to assembling the base and the final parts can get glued down and everything can get wired together. Every hour that I spend building this makes me realize how off I was coming into this so overconfident that I thought this would be a quick and easy project. So to answer the original question, what if I only had 24 hours to design and build something? Well, the answer is underwhelming. A day only gets me a half-completed build project that is still riddled with problems. But I don't design and build stuff to just get to the end quickly. I spend so long on my projects because I care about the stuff I make, the craftsmanship and the details, and I like challenging my creativity and exploring weird ideas to give them a chance to exist. So the reality is, I lost this challenge before I even started. I never had a chance to design and build this in 24 hours. But I'm okay with that failure, because it's not speed that I find enjoyable. It's the exploration and process and problem solving and creating something new. That's the part I enjoy.